Right now I'd like to invite Professor Mary Loew, who is the chair of the Department of Biomedical Engineering, to come and give a couple of comments on behalf of George Washington.
Good morning. On behalf of the Department of Biomedical Engineering and George Washington University and the School of Engineering and Applied Science, I welcome you to the SEH, our Science and Engineering Hall. Our dean always talks about engineering and he's pointing out that this reflects the broad impact of engineering in almost all spheres of activity. And our departments within the School of Engineering make that evident. As far as biomedical engineering specifically is concerned, we are fortunate here at GW to be literally across the street from our hospital and our medical center and our medical school. And what this means is that we in BME have lots of ongoing collaborations with the clinicians and the basic scientists in the labs and in the hospital and in the various clinics. Okay. So now we're going to echo. Should we mute that again? Or can we use this instead? I think we'll. How about if I use this one, not the handheld?
30 seconds. All right, you should be good now.
Okay. All right. Thanks. So this proximity has made an enormous difference. It means that our students, both undergrad and grad, have an opportunity to spend time in the various clinics and the labs and to work side by side with some of our clinicians. It means that we can work to get data from various sources that we use in teaching and in research. And so this collaboration underlies a lot of what we do in BME. The intersection of the topics of today's meeting with biomedical engineering is substantial, and I'll try to indicate some of those intersections in the next couple of minutes. One of the things that we're doing in the School of Engineering is developing a set of what we're calling cross-cutting initiatives, initiatives that cross the traditional departments. The mention of tearing down silos was made, and that's exactly what we're trying to do within engineering. We're bringing together researchers from several departments to develop high-impact approaches to important problems. Within BME, we are developing an approach to advance personalized medicine by innovative engineering. And this particular initiative brings together faculty from biomedical engineering, from electrical and computer engineering, from computer science, from mechanical engineering, from engineering management and systems engineering, and from our medical school, to do three basic things. One is to engineer and connect using, for example, lab on a chip and wearables that can sense various physical and physiologic parameters, and point of care technologies. Second, to analyze and synthesize using big data analytics, for example, and high performance computing. And third, to empower through explainable AI, through the making of fair decisions, especially in low resource settings, and to deal with questions of intellectual property ownership and security. Clearly, all of these efforts require methods to protect data and systems, and sometimes, unfortunately, to recover from attacks. Another important area of our BME program is a master's program in regulatory biomedical engineering for devices, not for drugs, which many other organizations have, but for devices. Our master's program in regulatory BME is the only one in the country that specializes in devices. And it's been going on for 6 years, very successfully, and we're now going to expand it to be completely online starting in the fall, so that people from all across the country, we hope especially people in the medical device industry, will join the program and proceed as a cohort, that's the way the structure will be, through this curriculum of courses that will lead to a master's degree. Clearly, in the area of medical devices, security is an essential consideration. And we have one of the courses within this curriculum will be dealing specifically with cybersecurity as it applies to medical devices. You as a group know far better than I the threats to security and privacy that we face. And it's clear that all of the topics that I've mentioned are potential targets for threats. My own work in medical imaging and image analysis, for the most part, doesn't deal with those issues. But we do have a project in anonymization of CT and MRI head images so that the face cannot be reconstructed from the data, but the diagnostic information is not lost. This is but a tiny part of the overall intersection of today's subjects with the healthcare enterprise, from research to technology to the clinic. We are very honored to host the CyberMed Summit. The all-star cast of speakers surely will identify new needs and approaches that will be a long-term benefit to all. Welcome again to GW, SEAS, and BME, where our graduates are making a difference.